Hello everyone, I hope you are well. Welcome to our lesson carrying on with C5. So first thing I would like you to do please is go to page 151 in your Caboodle book and look at question 3. Now you may have done this last lesson, it was an extension task at the end of the lesson, but I really want everyone to have had a go at it. So if you did do it last lesson, fantastic, you don't need to do it again. But if you didn't do it last lesson, go to page 151, look at question 3, and then we're going to go through the answers on here. So here we are, page 151, question 3. Pause the video, go do the question, and then I'm going to go through the answers, assuming everyone's had a go at it. So, assuming you have all done question 3 now, refer to the graph of rate against concentration in figure 3. So let's go up and find figure 3 here. Here we go. The rate of reaction increases as the concentration of hydrochloric acid increases. So on the bottom, the x-axis there, you've got concentration and then you've got rate of reaction per second up the side. 3a, estimate the rate of reaction at 1.8 moles per decimeter cubed. So I'm just going to, I wonder if I can draw on this. Ooh, I've never drawn on here before. Okay, right, let's try this. So 1.8, bit wonky, but hey ho. I hope you're enjoying these noises. Rate of reaction I'm saying is 0.048, not quite 0.05 per second. Okay, so that's my estimate for that one. Oh God, now I've got to try and move the page down. How do I do it without doing the pen? Okay, turn the pen off. Oh no, it's still going. How do I get rid of it? Oh gosh, I can't even look at. I'm so sorry. This is the worst video ever. 3b. Compare the rate of reaction at 1 mole per decimeter cubed and 2 moles per decimeter cubed. In this particular reaction, explain what happens when the concentration of hydrochloric acid is doubled. Okay, let's do this. So let's go for a blue, nice blue. So at 1 mole per decimeter cubed, that is, let's zoom in here, what have we got? 0.014, I'm saying, and at 2, was 2, wasn't it? Yeah, moles per decimeter cubed. Was here. Which is 0.059 really, moles per decimeter cubed. Okay, so what can I notice about this? Okay, good thing to do is take your calculator and to divide one by the other. Then you'll find out how big one is compared to the other. So I'm doing 0.059 divided by 0.014. What have we come out with? Okay, so it's about 4 times as big. So, let's get rid of this. There are 4 marks there, it means we're going to have to write quite a lot. What can I notice? The rate of reaction at 2 moles per decimeter cubed. It's not picking up, in fact I'm writing cubed there, sorry. There is a little 3 popping up there, but it's not coming up. Is, why is it not now writing? Where's my pen gone? Okay, right, I'm sorry about this. I'm going to have to do this on another slide, aren't I? This is just not working, right. Let's go here. So, rate of reaction at 2 moles per decimeter cubed is approximately 4 times as large as the rate of reaction at 1 mole per decimeter cubed. Okay, so that's a headline figure. You'll notice I didn't just write what they were. So in fact, let's write what they are here. So rate of reaction at 1 mole per decimeter cubed equals 0.014. per second. Rate of reaction at 2 mole per decimeter cubed equals 0.059 per second. So I've written out what they were from the graph. Fine, that'll get me points. I've then done a bit of analysis by dividing one by the other and finding it's about 4 times as big. That'll get me extra points. It's a really good thing to do in your exam question. So please, if you are ever doing something like this, don't just write what they are. Do a bit of comparison. Oh, it's 4 times as big. Oh, it's half the size, etc. Then let's try and explain it. This is because with an increased concentration of acid, there will be more collisions between particles, which increases the rate of reaction. There you go. So you'll see I've explained it, I've done a bit of analysis, and I found the numbers off the graph. That's how you're looking to get those marks. So, question done. Let's move on to today's lesson. Today we are looking at surface area and rate of reaction. Now there are very few notes for today, you'll be pleased to hear. So yeah, nice and easy. First bit is effective surface area on the rate of reaction. If a solid is split into several pieces, the surface area increases. Now, people do not like this, so let's just take a moment to really examine it. On the left-hand side there is a block, and it has a fairly small surface area. You know, it's got its outside bits, but it's not much. If I cut that block in half, can you see that suddenly I can access the inner bit of the block, so I've increased the surface area. If I cut that in half again, suddenly look at all the extra area that I'm able to access in comparison to just having a large block. So although it seems very backwards, the smaller the particles, if you have the same amount of stuff, if you have the same volume of reactant, but you've split it into smaller particles, you've massively increased the surface area. So this means that there's an increased area for the reactant particles to collide with. Therefore, the rate of reaction increases with surface area. And I'd like you just to add, so copy that down, and I'd also like the diagrams, but if you can please add a sentence saying, a powder has a much larger surface area than a block, so a much higher rate of reaction. Okay, and that's it. In terms of notes, I told you there really weren't many, so yep, get those down, and I shall see you soon. Thanks everyone.